Hello guys, welcome to this new video. This one is a requested question for this number 11. It is a combination of vectors and transformation question. Okay, so first one here we have PQ equals to this vector. As you can see, it is this direction. Now we have QR is in this direction. Question number one, we have to find the magnitude of PQ. Pretty easy. We just have to find using the formula. So first one is 12 square plus 35 square. Now you may ask why I don't write minus 35 is because when you square something, it is always going to be positive. So you can just ignore the minus sign. So let's do that. 12 square plus 35 square is this square root. That should be 37. So first one will be 37 units. Now for part 2, we have to find PR. So beginning from P, we have to go to R. So from P, we can go to Q, and Q go to R. So let's do that. PQ is 12 minus 35, plus QR is 14. That should be 16. So what is minus 35 plus 14? That should be 21, minus 21. So that should be PR. 16 minus 21. Now for part 2, we have, given that T is a midpoint of QR, find PT. So T should be somewhere around here, which is a midpoint of QR. Now to find PT, we have to begin from P, go into T. So P, first we go to Q, Q then go to T. So PQ is given to you by 12 minus 35. Then QT is just half of QR. QR is 14. That will be 12 minus 35 plus 7. That should be 14 over. So minus 35 plus 7 is minus 28. So your answer for part 2 is 14 minus 28. Now part 3, we have PQRS is a parallelogram. The coordinates of the point R is given by this. R is 6, 16. Now we have to find the coordinates of S. So first question is, we have to know what does a parallelogram looks like. So it looks something like this, with this side and this. So you have something like this, where these two sides are equal and parallel, and these two sides are equal and also parallel. So basically, this and something over here has to be same direction and same length, and this also same thing. So let's see. Let's make a drawing here, an approximation to see where can be your S. So this has to be in the same direction. So let's do that. And this one has to be in the same direction. So approximately the point S should be about here. So we have to find the coordinate. So one thing we realized that since it is a parallelogram, these two has to be in the same direction. So SR has the same direction as PQ. So basically SR is equal to what? Is equal to OR minus OS. OR has been given to you by this one, 6, 16. OS we don't know, XY, and the direction is the same as PQ. PQ has been given to you by 12 minus 35. So now we have to solve for XY. So let's do this. Let's do this over here. So XY, you make those to become subject of formula. You will have 6, 16 minus 12, 35. That should give you minus 6, 16 minus 35, that should be 51. That is your point S. So your answer, S will be the point minus 6, 51. That is for part A. Now let's move on to part B for this transformation question. So here we have a triangle ABC. First question, we have to find the area of triangle ABC. Now, usually, how do you find area of triangle? You would say we use half times base times the perpendicular height. So let's play with our diagram to see how can we do that. So if you were to extend this line here and this line over here. So to find the triangle ABC, we can first find the area of the big triangle and then minus the small triangle. So let's do that. Area of the big one will be half times base is 1, 2, and times height is 1, 2, 3. And minus the small one, half times base, 1, 2, height is 1. That should be 3 minus 1, that is 2. So your area will be 2 units square. Now for part 2, we have an enlargement of scale factor 4, that is important here, maps triangle ABC onto triangle LMN. The point A maps onto the point L, tan 3. So tan 3 will be right here. That is your point L. Now question part 1 is to find the coordinates of the center of enlargement. So as you guys know, by joining the point to its image, we can find the center of enlargement. So let's join those two and see where can be your image. Your point of enlargement, your center of enlargement. So your center of enlargement will be on this left hand side of this line. Now the scale factor has been given to you by 4, and we know that the distance from the center has to be 4 times to get to here. So by observation, you can see that the center of enlargement has to be this point. Why? We can check why. Because if you were to count, we have 1, 2, 3. Now if you enlarge this by 4, that will be 3 times 4 will be 12. So you will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is exactly on the point L. So that's how you can find the enlargement, the center of enlargement. By observation or by trying out, you can see which one of those points will correspond to the scale factor of 4 to give you this image. So your point will be -2, 3. Now for part B, write down the area of triangle LMN. So as you can see, LMN is obtained after a enlargement of scale factor 4. So since we have an enlargement, the area will not be the same. It has to be enlarged by a factor of 4. So first, if you were to compare the sides, so let's do that. So to compare the, not sides, the scale factor, at first it was 1, then it was enlarged by 4, right? For 1, it was equal to 2. What will be this one? So you have to remember, the scale factor is a scalar, so it is a unit is only linear. Now we have to find the ratio of the areas. We have to square both sides. That will be 16 to 1. So the ratio of the areas is 1 to 16. So if 1 was equal to 2, 16 has to be equal to 32. So that will be your area of LMN, 32 units square. So just to re-explain why we have to do 16 is because at first we see that the scale factor is 4. Basically we say that the initial scale is 1, and we have to change that to 4 because it was enlarged by 4 times, right? Now this is a linear, this is centimeter for the sides. If you were to compare the corresponding sides, then you will use that one. But now we have to compare the areas, because area, as you can see, it has to be centimeter square, for example. Now how can you change this to square? We have to apply square on both sides. You will have 1 and 16. So that will be the ratio of the areas, 1 to 16. Now this is ABC is 2 area, so 16 will be 32. That will be your area for part B. Now for part 3, A shear with the x-axis invariant maps the triangle ABC onto the triangle DEF. Now the point A maps onto the point D, 7, 3. 7, 3 will be right here. That is your point D. Now part A, find the coordinates of E, which is the image of B. So to know this, we must first find the shear factor. So let me show you how to find the shear factor. So you first have to go to this point and find the distance between your invariant line. It is 1, 2, 3 squares. So you write down 3 on below. Now for the image from the point A, it is 1, 2, 3, 4, 5, 6. It is 6. So the shear factor is 2. Okay. Now find the point A, image of B. So going to point B, the distance from the invariant line will be 1. So you have to times 2 because of your shear factor. So 2 will be 1, 2. It will be right here. That will be your point image of E. So E is given by the point 3, 1. Now let's say, for example, what will be the image of the point C? Because it is on the invariant line, it will not move. Okay, it will be the same thing. Now the last thing will be the point part B. Write down the area of triangle DEF. So something you guys should know is that whenever you perform a shear, the area do not change. So the area will be the same, which is 2 units square. Now let's say you may be confused sometime. Let's see if we can find the area of that shape, right? Let's say you don't know what to do. You will join all the points. You will join all the points and you can just find the area directly. So how would you find this area of triangle? This is the point not D, sorry, this is not D, this is the point E, F. So same trick that I showed you. We can just find the big one minus the small one. You should get 2 as well. So let's try that. Why not? Let's try and show you if that is right or not. So let's see, I joined this with this one. And we have 2 triangles here. So we want to find this one, right? We want to find area of this one. As you guys know already, how do you find area of triangle? Half times base. Base here is given to you by this, which is 1. So half. So let's write down half times 1. And the height is the perpendicular height, which is 1, 2, 3, 4. Times 4. That should be 2 as well. So your area is 2 as seen on the diagram as well. But hey, that should be just 1 mark, so it should be pretty simple. So that is the question number 11. So I hope that was somewhat helpful. As always, if you guys have any questions or requests, let me know in the comments. I'll get back to you as soon as possible. Don't forget to like and subscribe. It helps me a lot to make more videos. And thank you for watching. I will see you soon.